Wood is never static. It breathes, swells and shrinks depending on the conditions of its environment. This balancing act is described by the equilibrium moisture content, or EMC, also known as the point where wood is in moisture balance with the surrounding air. Knowing how to calculate the EMC allows engineers, architects and woodworkers to predict how timber will perform indoors. Will it swell, shrink or stay stable? The answer lies in temperature, relative humidity and a set of formulas that describe the physics behind wood's hygroscopic behavior. Let's break this down. The equilibrium moisture content, expressed as a percentage, can be calculated with the following formula, where EMC is the equilibrium moisture content in percentage, H is relative humidity, or RH in decimal form, so 50% becomes 0.50, W, K, K1 and K2 are coefficients depending on T, and T is the dry bulb temperature. This formula may look intimidating at first, but it's built on a straightforward principle. Wood interacts with humidity differently at different temperatures, and each coefficient captures that effect. The original reference formula from BioResources defines the coefficients in terms of temperature in Fahrenheit. This gives us, with these, you can calculate the equilibrium moisture content for any combination of temperature and relative humidity in Fahrenheit. Since most of the world uses Celsius, as I also do myself, let's rebuild the coefficients directly into degrees Celsius. This avoids constantly having to convert temperatures by doing 1.8 times the degrees in Celsius plus 32 to use the EMC formula. The EMC formula itself stays the same, but the coefficients, after expanding and then simplifying them, become, here T is in degrees Celsius. Let's put this into practice. Imagine an indoor environment at 20 degrees Celsius with 50% relative humidity. First, convert the humidity. So H equals 50%, which equates to 0.50. Then calculate each coefficient at T equals 20. And plug these into the EMC formula. Solving this step by step gives us an EMC of around 9.29%, which matches with what we'd expect for wood in a heated indoor space. This formula isn't just academic. EMC predicts whether wood will shrink, swell or stay stable. In high humidity environments, the EMC rises, leading to swelling and the loss of strength. In low humidity environments, the EMC drops, causing shrinkage and possible cracking. Equilibrium moisture content is the hidden regulator of wood's behavior. With just temperature and relative humidity, we can predict how timber will adapt to its environment. Whether in Fahrenheit or Celsius, the formulas mentioned in this video give us the power to design with confidence, knowing how wood will respond. If you'd like to try calculating EMC yourself, or explore this infographic that shows common indoor conditions with their corresponding EMC values, check out our Patreon page linked in the description. And if you want to dive deeper into how moisture affects wood, take a look at last week's video. Stay informed, stay inspired. TimberTalk.